Design by Decay, Decay by Design is a project that responds to the questions on how to design a world without waste and how biotechnology might play a role in that. My response is to recognize that as an architect and designer, all I do is design waste, or what will be waste. And if that's the case, then I should try to design waste that I can live with, in-site and on-site. I wanted to design waste as nature does, as inputs for future organization rather than only as the result of breakdown. With the assistance of Ginkgo scientists, this project explores how to organize decay using enzymes, fungus, bacteria, and other biological agents as ways of composing and decomposing matter at the same time.
It was taking a step back and asking really, really interesting questions around that bigger question of how waste exists in biology, or how decay is part of biology, and how decay and renewal work together.
My base material system included biocomposites of chitin, cellulose, and pectin, derived from the exoskeletons of shrimp, tree pulp waste, and fruit skins. These materials can be combined in different ratios to form different bioplastics that are environmentally responsive. I combine enzymes derived from fungus, bacteria, and human saliva into the bioplastics, using the enzymes to transform the material rather than simply destroy it. This was degradation as a fabrication process, and was done with the guidance of Dr. Josh Dunn.
One thing that I think is interesting about the notion of a circular economy is it leaves something out. We don't want to just recycle and reuse and degrade everything we produce, but there's a tremendous remediation part as well. So in addition to this cycle, we actually want to be pulling a bunch of things that are already in the environment, so microplastics being a prime example, back into this cycle, or even shovel some of it out of the cycle to the point where it's stored carbon once again.
With Kyle Kenyon, I was able to test different strains of Streptomyces on my biocomposites. Streptomyces is a common soil bacteria and secondary decomposer, which produces vibrant pigments in jasmine, the compound responsible for soil smell. Finally, with Dr. Mingyao Wu, a fungal engineer, I used Aspergillus niger, a black mold, and Trichoderma viride, a green mold, in fungal co-cultures to transform different materials and objects. This included degrading patterns into bioplastics and coloring wood carvings designed with increased surface area for maximum colonization. My goal in using these material systems and these biological agents was not to make a low carbon footprint object or upcycle waste. Rather, it's to support a different mode of design, where the process of making and breaking is provisional and not just consumptive, and to redistribute value away from permanent materials that destroy ecosystems onto transient ones that restore them. The struggle in a design practice such as mine is to learn to accept the embedded tensions, where material and biological agency sometimes work in contradiction to what I planned or what I'm comfortable with. It's a struggle for industry to accept this inconvenience as well. But given our time of climate crisis, it's no longer an option to design only for human convenience. Our survival depends on changing our attitudes.